Thank you so much, and thanks also to the organizer of Calm. It's really a great conference so far, my first time here. I'm really looking forward to meet and talk with a lot of people about their work. I'm joined here by Dongyang and myself, Imanol Schlag. I'm a research scientist at the ETHI Center, and Dongyang is a postdoc at EPFL. I'm very happy to present our work if performant LLMs can be ethical. And so about a year ago, to put things a little bit into context, the LLM effort of the Swiss AI initiative was in a sort of preparatory phase as the supercomputer was not quite ready yet, where we were collecting and looking at data for the training of a very large and fully open model, which eventually became Apertus and the Apertus family. And so, as you know, there's a growing wave of lawsuits and rumors as well about the use of copyright protected content in AI training and its problems. And there is various media articles that also sort of highlight this difficulty. This essentially prompted us to be very careful in how we developed the Apertus models, and prompted us to do one of our own evaluations, which I wanted to point out here, which might be interesting as it is looking at the legal arguments behind, the legality behind training a large language models, specifically in Switzerland, but also Europe. And so this brought up a few specific things we wanted to do in order to develop this model in a responsible fashion, of which some of them are being presented as well at NeurIPS, coming up as a full paper, as well as in our technical report, which we linked on the bottom. And what we are talking here specifically is about how we respected the AI opt-out and the effect it has on the model itself. And so there is already a mechanism there for people to opt out from crawling. This is the robots.txt mechanism, where domain owners can have a machine-readable robots.txt file that is right in the domain that can be used to opt out from certain crawling mechanisms. And in recent years, there have been numerous numbers of crawlers that can be sort of specifically associated with collecting training data, just as listed here. We've taken the 13 crawlers that we were considering to be directly linked with AI training data, and we applied them to our own data that we collected in order to respect the author's decision. And so one disclaimer here to make is that this robots.txt is not necessarily a training opt-out, but it's a crawling permission, although so this is only an approximation, but it's the best we could do at scale. And so what we see when we look at snapshots from Common Crawl throughout the years is that there has been, since mid-2023, a stark increase in opting out, especially when it comes to the domains that provide the most data. And so this prompted us with two research questions that we addressed in this work, which is it possible to train a performant LLM that respects data owners' opt-out requests? And also, if not, can we measure the impact of enforcing such a compliance, which then this compliance gap is what we wanted to keep track. And so there are two main issues here, which is that documents from opted-out content publishers, they can already exist in previous snapshots, as Common Crawl has been creating snapshots throughout many years. And so what we do is we apply these rules based on the robots.txt that we collected by January 2025, retrospectively as well, to any sort of data from that domain. And also there is a massive number of domains, many of them that are not available anymore, which brings up lots of technical challenges as well to crawl at scale, which is why we limited this work to the top 1 million domains in English and the top 1 million domains in non-English. And so by doing so, we lose about 8% of our English data and about 4% of our non-English data. And to talk more about the results, I'll hand now the word to Dongyang.
Thanks, Imanol. I'm Dongyang, and I will continue from here on. So since we have seen a lot of data opt-out, so what are the opt-out data like? So we label each document by the topic and format domain, and we summarize the top filtered out domains. So in terms of topic, the top filtered out domains are science and tech, health and history, and in terms of format, the top opt-out domains are newspaper articles, knowledge articles, and nonfiction writings. So at first glance, it seems like we have filtered out a lot of high-value informational content. But apart from that, we also filtered out a lot of non-permissible content. So to check that, we did a 50-gram match with content from non-permissible URL domains. And we found the matching rate is reduced, as in this table. However, the overlap is not zero. Why? Because, so first of all, content republishing is a big thing. So we always see through forums or personal blogs, there are people like reposting newspaper articles, for example. And second, the open source information can appear on those non-permissible sites. So do these data matter? We have to define an important concept, which is data compliance gap, or DCG. So basically, we define it as the downstream performance gap between models trained on compliant versus non-compliant corpora. And there are two ways of measuring it. So first of all, we can train two models side by side, one on compliance corpus and one on the non-compliant one. And the result, downstream task performance, is a DCG. And this measure is super expensive, as we need to train two models from scratch. So we provide a cheaper way. That is, we take a compliant checkpoint, and we do continual pre-training, or we call cooldown, on compliant versus non-compliant data, and then the resulted gap is also the DCG. So the following experiments, we always use the 1.5B llama-like models, and we train on 100B tokens sampled from FineWeb Azure corpus. So first of all, we present our first result. We did different pre-training runs using compliant versus non-compliant data. And here we report the 10-task average on general knowledge understanding. And surprisingly, we did not notice any performance gap. So it seems like pre-training on compliant data does not impact general knowledge understanding. Why is the case? We have first thought it's because the content republishing, or it can be some knowledge can be supplemented by other sources. To check this, we did one interesting experiment. That is, we removed the entire newspaper domains. So we found this comprehensive newspaper URL domain list with more than 1K domains. So we first filter out those newspaper articles, and then we did a decontamination step. So this whole process resulted in 14% token loss, even from the compliant corpus. And for a sanity check, we checked the New York Times 50-gram match rate. It drops to 0.012%. So this decontamination step is very successful. However, surprisingly, newspapers are still not as important as you would expect. So basically, the DCG is still close to zero. But is there really any DCG at all? So far, we have checked general knowledge understanding. Now we'll go to specific knowledge domains. So here we take the Pinocchio benchmark, which measures factual knowledge from different aspects. And we indeed can see like noticeable DCG in structural and adversarial knowledge. What do they mean? So structural knowledge is knowledge stored in structural formats, for example, information boxes or tables. And adversarial knowledge is to test the resilience of LLM against strategically modified inputs designed to mislead. So in these two domains, we're able to see some DCG. And if we recall, the top filtered domains are actually rich in structural and factual knowledge. So it's no surprise. Yes. Okay, so far we have identified which knowledge area is affected the most by compliant training, but which data is actually the most irreplaceable. So here we use our measure tool. So basically we reintroduce domain-specific non-compliant documents during the cooldown phase to the compliant checkpoint. And here to amplify this impact, we did a very long training. So basically we train on 1.6 trillion tokens using compliant data, and then we cool down on 100B tokens. So here, basically, we're able to observe a consistent DCG when non-compliant medical domain data are introduced at a later stage of the very long training. but these we did not observe in other domains. Yeah, so far we have identified so many compliance gaps, but what are the benefits of compliance training? So as we saw before, so the compliance corpus has like less non-permissible content. So technically it should lead to reduced memorization of copyrighted articles, which is actually indeed the case. So here we check like the 3 different measures of verbatim memorization, and we did notice like drop in values with compliant training. However, like when we check factual understanding, which is the knowledge grounded in those newspaper articles, we did not notice any performance drop, so which is great news for us, because that means compliant training reduces verbatim memorization of copyrighted articles while preserving key knowledge derived from these publications. So after showing so many evidence, can performant LLMs be ethical? My answer is yes, at least as of January 2025. And there is like further evidence from a PETUS model developed by EPFL, ETH, and CSCS. So basically adhering to data compliance, the PETUS models are currently leading among open models at 8B and 70B scales. So looking ahead, what are the future directions? So as of now, we don't notice a big DCG, but will the DCG like widen if more content owners opt out of AI training? So we have to keep check this. And second, if in the future we have to acquire like high quality data, like for training, what does fair compensation for content publishers look like in practice? And third, most importantly, can data compliant training become the new standard for the pre-training community? Yeah, those are my amazing collaborators. And thank you. We'll see you at the poster session afterwards. And here is our website where we provide the easy data filtering tools and also our paper. And also, I was asked by my professor to add this link. The Swiss AI initiative is hiring for research engineers. So if you want to contribute, you can scan this QR code. Yes, and we're happy to take questions.
And if you want to learn more about Apertus, we will have a presentation during the Milk workshop on Friday, 11:30.